Good morning, Tahmina Khan is here. In this video, I will explain to you the concept of kinematic of motion in a straight line, which is a syllabus of A-level mathematics option M1. It is paper 4, CAIE syllabus. So before I begin, let me show you. On the top, you can see the blog address, TKMaths.blogspot.com. You can find the link of all my previously made videos over here. And here is an email address, tkmathsfun@gmail.com. If you have any query and you want to send a mail, you can send it to me on this address. Okay, so first of all, let's discuss the requirement of this syllabus. So Cambridge syllabus, CIE syllabus says that you should have the understanding of the concept of distance, speed as a scalar quantity, and displacement, velocity and acceleration as a vector quantity. And then you should know sketching or interpretation of the displacement time graph and velocity time graph, and all these concepts about the gradient, what is the area under the curve in the velocity time. We will all see this into detail. Secondly, you should also know differentiation and integration with respect to time to solve simple problem concerning displacement, velocity and acceleration, and the formulae for the constant acceleration, which are called Sweat formulae. Okay, so we will see all this in at least 5-6 videos because all this cannot be covered in one video. So in the first video, I am going through the terms and terminologies which are used very often and very simple example of each one to understand all these. And then there are 3 main things which we will cover in the videos later. Number 1 is how to sketch a graph with the help of the explanation given to you in the question. Secondly, the sketch is given to you and you have to answer the question by reading that. Then the question which involves Sweat analysis formulae, which are about constant acceleration, and then differentiation and integration. So basically there will be 4 basic videos on these concepts. So let's start this first one. So kinematic of motion in a straight line. So what is kinematics? Kinematics is basically a branch of mechanics which deal with the motion. And here we will talk about motion in a straight line. And in this topic we are basically concerned with the relationship between the position, the velocity and the acceleration of bodies and how these changes with time. We will not talk about the causes of these changes here. So let's see what is the meaning of the term scalar. So in mathematics, a quantity that has only size or magnitude, it is called a scalar. So for example, time, we only talk about magnitude, distance, speed, energy, temperature. So these are those quantities which only need a magnitude to explain to them. We do not need a direction to explain to them. So they are called scalar quantities. Now vector quantities are those which need magnitude and direction to be explained properly. So for example, force, velocity, momentum, acceleration. So if you are talking about any of these quantity, you have to tell the direction and you have to tell the magnitude. Only then they are described properly. So these type of quantities are called vector quantities. Now let's see the difference between distance and displacement. Distance is a scalar quantity and displacement is a vector quantity. So I'm taking the example of this example to explain it. For example, a particle moves from 0 or origin from here till here and it covers 5 meters. Then it take a turn and go back 3 meters. So if somebody asks you what is the distance covered, you will say 5 plus 3. So distance is basically the whole path you have taken. Whereas displacement is the distance from the starting point to the end point directly. So this is your displacement. So how will you calculate it? The total is 5 and the backward this much is 3. So 5 minus 3 is 2 meters. So 2 meters, and you will tell in which direction? East. So I am talking about east. East is this direction. You can also say right hand side, left hand side with respect to origin. So this is up to you that how do you describe the direction. So basically you are saying it is the position of the object relative to some origin. So with reference to the point you talk about in which direction and how much or how far it is. So velocity and speed. Speed is scalar, velocity is vector. So velocity basically states how far the object is moving in a particular direction. And if I do not mention the direction and only talking about the magnitude at which the object is moving fast, I will say it is scalar. So just how fast the object is moving. So for example, I can say the aeroplane is going at a speed of 800 km per hour. So 800 km per hour is the speed. But if I say it is going in the northeast, then it is velocity. So magnitude with direction is called velocity. Then we need to see what is acceleration. So acceleration is the rate at which the velocity changes. So change in velocity divided by time taken. So for example, what do I mean by change in velocity? For example, in certain time period, what is the initial velocity and what is the final velocity? VF mean final velocity. So you subtract the two and you get the difference. So for example, when you start timing it, the velocity was 5 meter per second and then it was 10 meter per second. So 10 minus 5 is 5, and the initial time when the velocity was 5 was 1 second and then later 3 seconds. So when you divide the difference in velocities and the time period in which it happened, this is called acceleration. And the unit of acceleration is meter per second square. Now another very important thing is change of unit. So conversion of unit basically. So if it is speed and velocities are given in kilometer per hour or meter per second usually, right? So you should know how to convert, because if time is given in second and distance is given in kilometer, then you change it into meter, because the speed will be mentioned in kilometer per hour or meter per second. So for example, if it is given kilometer per hour, to change kilometer into meter you will multiply by 1000, and to change hour into second you will multiply by 3600. So to change 40 km per hour into meter per second, you will do what? 40 times 1000 and divided by 1 times 3600. So it will give you meter per second, 11/1/9. Okay. So conversion is very important when you are attempting the question. You have to see that units are right or you need to convert them. Now another important term, which is average speed. So average speed is total distance traveled in a total time taken. Mostly students make mistake here. If journey is happening in different interval, sometimes a student find out the speed of each interval, add it up and divide it by number of intervals, which is wrong. Average speed is total distance of the journey divided by total time. And what is average velocity? Total displacement divided by total time taken. So displacement is basically the distance from the origin, from the starting point to the ending point. That is mean displacement. So average velocity is displacement divided by time. Let's see the example here. For example, a man walks 400 meter due east in 190 second and then 100 meter due west in 50 second. So if I ask you to calculate average speed and his average velocity, so how you will calculate average speed? Average speed mean total distance over total time. So total distance is 400 plus 100, which is 500, and total time is 190 plus 50, which will be 240. So you will divide it. So let's see first of all average speed, and then we will find out average velocity. So here it is, which I was just explaining. Average speed is total distance over total time. So I'm adding up distances and I'm adding up time. So I get 2 whole 1 over 12 meter per second. This is my average speed. Now what is average velocity? According to the question, first 400 the man went to the east. So he is going like this. And then 100 meter west. West is again backward. So he's coming backward here. So 400 meter east and 100 meter west. So if I have to calculate average velocity, which is displacement divided by time. So what is this distance? It is 300, right? Because 400 like this and 100 like this. So now he is only 300 meter from the starting point. So average velocity is 300 meter and it is in the direction of east divided by 240, because total time will remain same. And when you divide, it is 1 whole 1 over 4 meter per second in the direction of east, right? So this is how you calculate average velocity. So now we will see what are the formulae for uniform acceleration, which are also called SWOT formulae. Okay, so we need to understand the letters, the meaning of those letters here first of all. So the letters are U, V, T, A and S. These are all small letters, right? And the formulas are for uniform acceleration, constant acceleration. Remember this thing. So U represents initial velocity, V represents final velocity, A acceleration, T for time interval or time taken, S is displacement. So the formula for motion with constant acceleration are, and you need to know them by heart, right? V is equals to U plus AT, S is equals to U plus V divided by 2 into T, which is also written like this. It is same thing. I'm just writing 1 over 2 separately. Now formula number 3. S is equals to UT plus half AT square. V square is equals to U square plus 2AS. S is equals to VT minus half AT square. I'm not teaching here the derivation of these formula because they all start and end up with a new formula very easily by substituting simple terms. But I'm not going into detail of all those. Simply the application of it, because that is not the requirement of the syllabus. So these formulae are called SWOT formula also. So let's see the example here now, the application of this formula. Later on I'll pick up the questions from the past paper. Right now I have just picked up from different books. So in traveling the 70 centimeter along a rifle barrel, a bullet uniformly accelerates from its initial state of rest to a muzzle velocity of 210 meter per second. So basically it is about the bullet which is coming through the rifle, the nozzle of it, and the velocity was 210. Question is saying find the acceleration involved and the time for which the bullet is in the barrel. Okay, so let's see here. Now this information I have gotten from the question because it was initial state at rest. It means U is equals to 0. So before firing the bullet was at rest, and then when it leaves the barrel the velocity is 210. And the distance of the barrel, it is written here 70 centimeter, right? Because we tell speed in meter per second, so I'm changing centimeter into meter. This is what I was talking about, that be very careful about the units given in the question. So your distance is this. Now question was talking about what to find out. Question was asking find out acceleration and time, right? So if I look at this information which is given to me here, using this formula V square equals to U square plus 2AS, I can find out acceleration easily. So I'm just plugging in the value of V 210, initial velocity is 0, distance is 0.7 of the barrel, right? So acceleration is 31,500 meter per second. And common sense says that yes, it should be very high because we know the bullet comes out with very fast velocity. Definitely it has very high acceleration at that time. And for finding the time for which it was in the barrel, I can use this formula. V is equals to u plus at. Again, the values are given to me. Acceleration I have just found from here. So I'm using it, and this will help me to get the time. So time is 1 divided by 1/52. Very small time, which is also perfectly okay, because the speed was so high that in a very, very short time it covers a big distance, right? So let's see another example now. The example to understand how to apply SWOT formulae. Okay, so in this example it is a particle is projected away from the origin and the initial velocity is 0.25. The particle travels in a straight line and accelerates at 1.5 meter per second. I would recommend when you are reading these questions, because in mechanics the questions are very lengthy, to make the scenario and to make it clear. Usually it is very lengthy, it's like a small paragraph. So always pick up the important information and jot it down separately. I'll just show you in a while. For example, in this question, initial velocity is given, acceleration is given, and question is saying how far particle is from origin after 3 seconds. So time is also given. So I have put down all the information here. Once you have the basic information here and what is asked here? Far, how far, which means distance is asked, right? So if you know the things given and what is asked, you can easily decide the formula. So now I'm using S is equals to ut plus half at square. If you notice, I have all the information except S. U is 0.25, T is 3, A is 1.5, T is 3 square. So I used calculator and I got the distance 7.5. This was part A of the question. So again, all the information put down on one side. Okay, so second part of the question is saying how much distance is covered in the 4th second. Now this is very important. 4th second mean, can you think about it? It means the distance covered in 4 seconds minus the distance covered in 3 seconds. That is called the distance covered in 4th second. So that's why I am doing S. This 4 is representing time in 4 seconds minus distance covered in 3 seconds. And the same formula I will use, which I have just used in part 1. And same values. Instead of T, I will write 4 now. And my answer is coming 13. In part 1, the answer was coming 7.5. So I will subtract the two distances and I will get the distance covered in 4 seconds is 5.5 meter. So let's see the last concept of this video. It will cover all the concepts we need to, the basic terms we need to understand. Then we will go into the detail of the topic. Now the last is acceleration due to gravity. So there are questions of dropping object, throwing it in the air, where the acceleration on the object is due to gravity only. And you know what value we use? Actually in the books it is 9.8 considered, but in Cambridge exam we use 10. It is always mentioned in the paper. So we will use throughout the gravity value 10. So the example is a ball is thrown vertically upward with a velocity this. So this is your initial velocity from a platform which is this much meter above the ground level. So it is 19.6 meter above the ground level. The time taken for the ball to reach the ground. So let's see the first part first, then I will go to the second part. So basically what is happening, you are standing here on the platform which is 19.6 meter above the ground. You are throwing a ball. Of course it will go up all the way and then it will come down. So time they are asking in part 1, it took all the way to go from the top till here. Now we will applying the concept of vector. The initial velocity is 14.7, right? So I'm writing u is 14.7. When we are talking about vectors, we only talk about the final distance, displacement from the origin to the last point. So I'm talking about the ball is hitting the ground. So this is my displacement, right? if this is my origin, so downward it will be negative, upward it is positive, because according to vector convention, the two opposite arrows always taken with opposite sign. So I'm taking this u plus, so I'm taking this direction minus. And when you throw the ball up, and because acceleration is always acting downward, so when the object is gone up, the acceleration is minus 9.8, or if you throw it down, the acceleration is plus. So when it is coming down, it is plus, when it is going up, it is minus. Now here I have written minus 9.8, right, general. Otherwise, if I will look at it from exam point of view, I will take the value of 10 here. So I'm repeating, from this point I'm throwing the ball up. So at this particular instant, u is 14.7, acceleration is minus 9.8, because it is going against gravity and it is slowing down, and the distance is 19.6. I'm not talking about the whole thing because I'm talking about vector method right now. So these are the values I have, and I'm using this formula to find out the time, because question was saying the time taken for the ball to reach the ground. So I will solve this quadratic equation and get the time. So here I have solved the quadratic equation, you can see, and I did not show here all these steps because this is a prerequisite knowledge. I think you should know how to solve quadratic equation. So time is coming 4 seconds and minus 1. Negative time is not possible, so this is out. So this is the time after which the ball will hit the ground. The second part of the question is saying find the velocity with which the ball will hit the ground. So now I need to find out v. So u is given to me, a is given to me, and t I have just found. So u is 14.7, a is minus 9.8, and t is 4. So minus sign here is indicating that it is downward, right? You are hitting with this velocity downward because u was upward. So negative sign shows that the ball hits the ground with the downward velocity of this. So one thing I would like to tell you here, let me go back to the diagram. If you want to do it in steps, which will be very long, but you can try it, right? Answer will come same. So when object will go from here and reach to the highest point, at this point v is 0, right? So if you want to do it in steps, you can do like that also. Find out the time taken to go from here to here and the time taken to come all the way from here. So I'm just giving you idea, you can try it out. So you use your constant acceleration formula and do it in 2 steps, and you will see the time and the velocity with which it will hit the ground will come same. But it will be little longer method because you need to find out this distance also, then this time also, then this distance you will know. So you will find out this time, add up this time and this time, and then find out this velocity. So it will be little longer method. So with this I end this video. Thank you very much for watching the video. In next video I will cover the sweat analysis questions, little complicated, and then about sketching, interpretation of distance, time and speed time, and after that integration and differentiation. Take care. Allah Hafiz.